Coral reefs are structures that are entirely built from living organisms. Even though they cover less than 1% of the world's ocean floor, it has been estimated that about 25% of all marine biodiversity depend in one way or the other on the presence of coral reefs. They are not only among the most fascinating ecosystems of the world, they also represent a tremendous economic asset. For example, reefs form nurseries for many of the ocean's fish, and about 500 million people have some dependence on coral reefs for food or income from fishing. Furthermore, reefs prevent coastal erosion, flooding and loss of property on the shore, and therefore they reduce human costs of destruction and displacement. Tourism revenues generated by coral reefs are also significant and can be a source of much needed income for some of the world's poorest nations. If temperatures exceed the long-term average of the hottest month by only 1 degree for a few days to weeks, corals will start to bleach. In addition, our research at the University of Southampton has shown that disturbances of the water quality can render corals more susceptible to heat-induced bleaching. Corals are really fascinating organisms. Therefore, I'm very excited to see how Glenn and other collaborating artists will build on the natural beauty of corals to find new ways to communicate our science.
Well, I've chosen this piece of coral. This is one of the specimens from Southampton University. As an artist, I know very little about this, so this is where art meets science. And in my view, when art meets science, it gets very, very exciting indeed. And these two disciplines working together can make the whole experience for the viewer much more exciting than those individual parts. And the sum of the two can be very exciting indeed.
So what got you interested into corals and into coral bleaching?
Well, as a sculptor, I work obviously in 3 dimensions, and the main thrust of what I do tends to be environmental. And I was thinking to myself, one area that I've never dealt with is the ocean itself.
Corals are true animals, but in the case of warm water corals, many species form a vital partnership, a so-called symbiosis with microalgae. Photosynthetic pigments of the algal symbiont shines through the tissue of the host and contributes to the brownish appearance of many corals. In addition, some coral hosts produce green or red or purple pigments that optimize the light climate for the benefit of their symbionts.
Okay, Jörg, this marble that I'm hoping to use, as you can see, is it's white. It's a slightly ivory off-white. The coral I've seen, and I've seen it occasionally in tourist shops and so on, and in your laboratory, is white. So can you tell me what why it's white? What is this bleaching all about?
So a coral in itself, it's an animal, so it's a living thing. It's not a dead stone. It's limestone skeleton covered by animal tissue, but inside this animal tissue you have microscopically small algae sitting inside, and they're doing photosynthesis and they're providing the animal with essential food. And if there are stressful environmental conditions, and if there's, for example, heating, or if the water quality is going bad, then this symbiosis, so this relationship between these two partners, between the algae and the animal, that breaks down, and the little algae are lost from the tissue. And while the tissue can be still alive, you will then start seeing the white skeleton from underneath. And it really strikes me with this marble block that you have a sort of similar situation. So here's the weather exposed side, and you have all these algae and mosses and lichens growing on them. And as the symbiotic algae in the coral, those are photosynthetic organisms. So they have photosynthetic pigments like chlorophylls, and that renders this surface here a little bit of green and grayish in tone. And underneath you have the limestone skeleton. And so it really is a nice coincidence to see that here, because if you take off then this living bit, then you suddenly end up with a white structure of the skeleton.
And that's similar, is that similar to coral?
And that is what would happen during coral bleaching. So in the first place you would lose these symbiotic cells with the photosynthetic pigment, and you would see the white skeleton. And if they don't recover from this bleaching, the animal will die, and as a consequence the live tissue will go, and then you will just see the bare skeleton.
Yeah, it is interesting. I mean, when I read Jorg's report, and one of the terms he used to describe bleached coral was limestone skeleton. So it struck me that coral as a form would be very interesting to carve in stone and develop an idea around that. And this lump we have here, which is what I hope to use, is not limestone, but in its past life it was limestone. It's now marble, which means that in geological time it got changed by pressure or heat or a combination of both. And so this felt like a perfect material.